Adaptation is obviously very local. There are some global adaptation issues, like, let's say, changes in refrigerants, replacing HFCs. Everybody has to do it. That's an adaptation that also works for mitigation in terms of reducing greenhouse gases. But most of the time, the impacts are very local, so all global warming is local. To repeat again, nobody lives in global mean temperatures and global mean sea level rise and so on, which means the impacts informations and the adaptation needs obviously work best when you have reliable regional and local information. Even for a country like India or any other country you can think of, China, US, you can see the range of values for any output. This one is looking specifically at runoff. So what they have done here is take a hydrology model and force it with climate outputs from many different models, and they are looking at regions where number of models agree on giving increased runoff. So there are only few models agreeing in these red regions, whereas at higher latitudes where we talked about polar amplification, snowmelt and other things, many more models seem to agree on the fact that projections will result in increased runoff. So how do you deal with these kind of uncertainties? But when you do online modeling as opposed to offline modeling, so this is runoff directly simulated by these different climate models which forced the hydrology model here, then you can see that the map is different. There are still regions where only few models agree on increased runoff into the future, which are somewhat similar to these maps but slightly shifted. It has gone from a focus on the southeast US more towards the central western southern US. This is shifted maybe a little bit to the north, and number of models is higher here than here. So this problem remains in terms of the details of the model formulations and so on. And in the context of adaptation and mitigation, we have to remember that mitigation is about reducing our impact on climate change, let's say by reducing emissions. So you can make decisions based on some uncertainties with a higher risk, let's say, or a lower probability answer coming out of the models in terms of what is needed for mitigation. Let's say mitigation is about reducing deforestation to reduce emissions. This is not something that's very uncertain, right? There are some issues, but in general, reducing deforestation and forest degradation is going to be good for mitigating our impact on climate change. But adaptation cannot tolerate as much uncertainty as mitigation, because if you are going to deal with water problem in some part of, let's say, the Gangetic Plain in India, or if you're going to do a big project like linking rivers, then you have to be sure that you are not moving water from a drying region into a region that's getting wetter. Presumably this has happened to some extent in China where river rerouting was done, but that is maybe more to supply the capital Beijing versus other places and so on. So there may be politics involved, but nonetheless you can imagine that adaptation requires reliable information at local scales. So this shows about how adaptive development can happen. So this is mitigation without negatively affecting humans and ecosystems. So you don't want to do maladaptation, as we will see later on. In other words, invest in something thinking it's good adaptation for climate change that is expected, but you end up actually degrading or being detrimental in dealing with the changes that will come upon us. So looking at components of climate related risks, illustrative adaptive development interventions and dimensions of adaptive development policies. This nice chart shows the climate risks and adaptive development responses. So this is just illustrating how institutional and incentive-based and information dimensions of policy responses to climate risks come together in concrete adaptive development interventions. But in practice, adaptive development interventions combine some aspects of each of these three dimensions. So in terms of components of climate-related risks, we have frequency and intensity of climate-linked phenomena, obviously, droughts, floods, extreme heat waves, etc. Exposure of high-value assets and infrastructures, so sea level rise and inundation and storm surge creating problems for high value assets and infrastructure, and in general preparedness and responsiveness is important for reducing vulnerability as well, right? And in the dimension of adaptive development policies, we have incentive-based interventions, we will discuss those, institution-based interventions, and information-based interventions. As I mentioned before, adaptation can be to reduce our impact as well as to tolerate the changes that are happening, so the managing the unavoidable kind of scenarios. But they can also be often targeted at making sure we can continue to do things as usual by taking care of the issues. For example, if water scarcity is going to affect food production, can you just desalinate and compensate for the lost dryness from climate change? Or can you just mine more groundwater? Is that going to be sustainable? Just using more air conditioning, for example, is an adaptation to warming, but air conditioning comes with greenhouse gas emission in terms of HFCs and energy use, so that's not going to be beneficial for mitigating climate change. So those kinds of options have to be considered. So in the adaptive development interventions, you have social safety nets for migrant agro-pastoralists, which is critical in some highly climate-sensitive regions, agricultural zoning for diversified crop production, so urbanization and loss of croplands and or deforestation for increasing cropland, or loss of cropland because of climate change are all going to be problems. Reduced subsidies for groundwater extraction in semi-arid areas. So in the context of food, water, energy nexus, for example, in India and other places there are examples where subsidizing electricity for pumping irrigation water for agriculture ends up costing too much in terms of excessive energy use, even when there is good rainfall. So even if the monsoon is good, sometimes irrigation is done, which also results in increased salinity of the soil and waterlogging and other problems. But if you provide free electricity, people are going to pump more water. So reducing subsidies is going to be important. Higher taxes and costs of infrastructure for settlement in flood-prone coastal zones. It's not just coastal zones. Actually, the Mississippi River catchment area, a lot of the occupation of flood zones has resulted in excessive loss due to floods, and land conversion to agriculture, it's the breadbasket of the US, also results in increased flood vulnerability. Okay, this is obviously especially important for coastal zones where sea level rise is causing a problem, but on the eastern seaboard, the hurricanes rapidly intensifying and slowing down and dumping more rain is becoming a huge problem as well. Early warning systems, provision of usable information and data, development of adaptive development standards. So only recently have people started to see preparedness and responsiveness as part of the adaptation plan. Typically it's thought of as doing something to take care of the long-term future, but being adaptive in responding to extreme events that are already being caused by climate change and will continue to be exacerbated is greatly reduced in terms of vulnerability by having reliable early warning systems. We talked about the S2S timescale, the subseasonal to seasonal timescale, which has become a global coordinated activity under the World Climate Research Program with applications to health, water, food, energy, and so on. That's now a big part of the adaptation as well. Okay, it's not just projections, but even short-term ready, set, go framework that we talked about before, where seasonal information used for readying the system to deal with coming extreme events. Set is when the extended range forecasts 2 to 4 weeks give you better information to allocate resources and prepare the plans. And go is when the short-term 1 to 10 day information makes it possible to reduce the vulnerability greatly by doing this. So it's a good example of what information demand will be for adaptation and adaptive development, going from preparedness and response timescales to multi-year and multi-decadal timescales, right? Obviously, the range of activities are different. One is about managing disasters and recovering faster. The other is managing water resources and energy and food production for the long term. So they are bigger projects, bigger investments, and bigger reliability on reliable projections needed for making those investments.